I'm Gretchen Murphey. I work for the California Department of Fish and Wildlife. I'm at the State of the Estuary Conference, and this is my poster on the effects of water year type on the size of outmigrating juvenile Chinook at Mossdale.
Okay, so it looks like, as is here in large type, that fish are larger in wet years.
In fact, they are.
Okay.
So 2005 and 2006 were wet years according to the VAMP study. So that's what we were using as our water year types because all the fish are coming out of the Tuolumne, the Stanislaus, and the Merced. None of the fish are coming down the San Joaquin. So because all those different tribs sort of have different water year interactions, we use the VAMP water year types. So the fish, in fact, are bigger when it's wet. Big shocker. So the next question we had was, are they outmigrating later? Is that why they're bigger? Is it that they had longer time in the river to rear? So I looked at outmigration time, and in wet years they do happen to outmigrate later. The magnitude of later varies between the different wet years. So 2005 was only a few days later than the dry years, while 2006 was like 19 days later. It was quite a bit later.
Mm-hmm.
So
and these are the median outmigration?
The dots are the average, and then all the bars are actual catch on each specific day.
Okay.
And these also are the averages, which are in the tables at the right, just so there are some numbers.
Gotcha.
And then from there, the next question was, all right, they're bigger, they're outmigrating later. Are they bigger because they're outmigrating later?
Right.
Seems like a logical step. So using a really basic growth rate calculation, which is mainly focused on rearing time and temperature, we're trying to determine if the fish should have been that much bigger. So I use the average temperature of all the tributaries because unfortunately the fish are not coming from one river, they're coming from three.
Right.
So I use that to calculate the predicted length based on just time in river and temperature. And I came up with these numbers. So the triangles are the average calculated temperature for the average calculated fish length for the tributaries, while the diamonds are the actual average lengths we found on trawl. So based on the calculations of growth rate, mainly focused on temperature and timing, the fish should have been about the same size in both year types, when actually in the wet years they were quite a bit larger.
Yeah.
Yep.
And so does this simple calculation have sort of implicit in it some idea of food availability?
No, because that's one thing that we can't really know, and that's sort of what we were trying to, mainly the question was the timing and temperature for size, because yes, it's likely if they're rearing on a floodplain, they probably have better food availability, which is what we're suggesting. But because these fish are coming from 3 different rivers and they all have different characteristics for when floodplains are inundated, what feeding ration could be expected to be on those, which some of them might be known and some of them might not be known. It was mainly the question of, if we're just looking at the simple timing and temperature, should they have been that much larger? So hopefully with some data on some specific growth rates from some of the rivers in a floodplain study one of my coworkers is working on, maybe we can pin it down a little bit better, but it's really hard considering there's 3 tributaries that are feeding into this. The fish are getting caught down here at Mossdale, everything upstream, and we don't necessarily know what ratio they're even coming into Mossdale at the moment.
From the 3 tributaries.
Right. So I'm hoping that maybe we can maybe there's data out there that I haven't found that I can use to maybe tease it out or come up with some other further study, but that's sort of the limitation of the data set we have, is that it's taking all of the San Joaquin tributaries, and that's the goal of the trawl basically, is to figure out how many fish are coming out of the San Joaquin system and get recapture and survival rates for coated wire tags in the system.
Gotcha. So was there also, so it looks like the size was bigger. Did you guys look at like lipid content or sort of the composition of the fish?
No, this is just taking data that we already had from the trawl and then using it taking what we had to see what we could find out of it. So no, nobody collected any samples from then. We don't have otoliths from then, so we can't just send them off for microchemistry to figure out where the fish came from. So I took what we got and did what we could.
And I don't know the San Joaquin system that well, but so the areas that they would be rearing this floodplain habitat, does that tend to be on the San Joaquin or in the lower parts of the tributaries?
It'd be in the tributaries. The San Joaquin, or most of the portions of it that I know of, there's not a whole lot. There's some, but For the smolts, which is what we're catching on the trawl, most of them we're thinking are rearing in the tributaries. So there's the lower portions of the river. Some of the rivers have been restored for floodplain habitat, so they inundate at slightly lower flows, as opposed to other parts that are very channelized where it's unlikely that there's floodplain inundation until it gets down really low, down towards the mouth.
Gotcha. Okay. Well, so I mean, the reason this is really interesting to me is on the Sacramento side, we're trying to look at with these models, sort of the potential for fish to rear in different habitats, and those habitats are really grossly defined right now. They're basically delta, bay, and river, and then floodplain, which is the Yolo bypass. And what we don't, and we're making some assumptions about where the fish rear as fry, and then we assume they then smolt in those habitats if there's space for them to rear, and then basically migrate out. And they don't do any rearing on the way, so there's no opportunities for compensatory growth after they smolt, and then
because they're trying to get out.
And then we're assuming that their size when they enter then has a big effect on them, depending on what the ocean conditions are doing. And so this is related to like some work that Brian Wells and Rachel Johnson and
we deal with Rachel for Odylus. They've got some of ours, and some of their conclusions have been a bit different from what we've found. I mean, we're suggesting, though, we're looking at the size of the fish, but that based on other data and studies based on other studies, fish that outmigrate larger have better survival. But I guess a study that Rachel's involved in is suggesting something different. And it depends on water year type, but it's based on what they've got in Odylus, and looking at, I think, fry survival rates. But in this case, the trawl's mainly targeted towards smolts. So anything that outmigrates as a fry, we don't really catch, and we're not really interested in them. They might be doing further growth downstream, but in terms of what's going on in actually our system that we're involved in, the San Joaquin system, it's more a question of, all right, what are the smolts doing? Because we have this tool that's already built and has this big data set.
Well, and then the other piece of it is that I don't know that there's much in the way of habitat for fry to rear if they get too much further downstream. I mean, I think that's another piece of this study is just to try and understand, with the current configuration of, Suisun Marsh and San Pablo Bay, like if there was a strong fry migrant component and it, that was part of a population structure, what would it actually have to rear in? And there's not much. So the otolith is then going to have an estuarine signature in it, but then it's another question as to where is that? I mean, it could be in the bottom end of the Yolo bypass or Cache Slough, or there's lots of other places where fish could basically rear and have that estuarine signal. That's probably actually pretty decent rearing.
Which may be a limitation of some of the otolith studies is all you've got is the signatures you can find in the water that you have. And I believe I've heard from some other information dealing with our tributaries that at times the signatures in the otolith from the Tuolumne and the Stanislaus seem really similar, and they're trying to track down possibly why. So things like that, within limits they can a lot of times they can figure out what river, but it sounds like there's a little bit of muddied in there, and I'm not really all up on that data, but sort of they go out and catch water and help them out because they're interested in trying to tack down a little bit closer what this other signature is.
Yeah. I mean, I think Nautilus has definitely been an interesting data source because obviously it does give you some idea of how fish may have distributed themselves. I know that they've started doing that with winter run as well, and they tend to come down and then basically find some place to go for a month or two before then starting to smolt and head out. And so, depending on where they go for that month can make a big difference in terms of
what they're going to see
and how big they're going to get, and what the potential is for them to migrate out at a decent size and all of that. So, anyways, this is a cool study.